Today we're looking at lesson 32, which is solving rate and ratio problems. All right, so the first thing we need to, I said lesson 32, didn't I?
Yes.
I meant lesson 31. So the first thing we need to have a look at here is definitions of important things that we're going to look at. These definitions will be on the Unit 4 vocabulary quiz, so kind of start filing these away and make sure that you understand the definitions that we're looking at. So solve rate and ratio problems. Now right out of the blocks we see two words here that we need to find, right? But they're not new definitions. Does anybody remember back from Unit 1 what a rate is? Now that's a rate of change. You can't really interpret rate that way without the two words of change.
Is rate like miles per hour?
Miles per hour is a rate.
It's like,
Gallons per minute.
it's like the big.
A rate is a ratio that compares different units. Okay? That was how we defined rate before, and that's how we're going to define it now. Ratio, you don't write these down because I'm going to give you better definitions in a second. A ratio is what? Comparison of two numbers by division. Exactly right. So a ratio is a comparison of two quantities using division. Okay? A rate is a ratio that compares quantities measured in different units, like feet per second. 15 apples for $6. 25,000 hits per month. Those are the types of, so 25,000 hits per month. That's my YouTube channel right there, buddy. Not. Okay. All right, a unit rate is a rate whose denominator is 1. Okay, and that's a new definition. A unit rate is a rate whose denominator is 1. A unit price is the cost per unit. For example, 55 miles per 1 hour. That's a unit rate. The denominator is 1 hour. Okay, so 55 miles per 1 hour is a rate. And then $2, a unit rate rather, $2.50 per box, that's a unit rate. Why is that considered a unit rate? Because it's the price for how many boxes? One box, right? If I did $8 for 2 boxes, that's not a unit rate. $8 per 2 boxes is $4 per box, right? So we need the unit rate. And what we'll use unit rates for primarily, unit rates are used for comparison, right? If you wanted to compare two things, a unit rate is going to be the way to go. Okay? What is the price for one thing to compare it? And if you notice, I don't know if you guys grocery shop much or if you go grocery shopping with your parents. You can look at in Kroger at the bottom of the little tag that's on the rack, there's a little price right there. It's called the unit price. It's the price per ounce or the price per pound or the slice or the price per slice, you know, whatever. It's the unit rate. So you can compare the cost of that easily to something else. So you can determine whether it's better to buy the 7-ounce bag or the 5-ounce bag, right? Because it'll give you the price per ounce. Right? That's a unit rate, and unit rates are good for comparison of quantities. For example, which is the better buy? And what do we mean by better buy? Which one is cheaper, right? And that's we're talking about cheaper. That we could talk about quality and other things, but 5 cans of tuna for $4.95 or 6 cans of tuna for $5.75. Now this is the kind of question on a test or quiz I'd be looking for evidence. Okay, I want evidence to suggest why one is better than the other. So what am I looking for here to compare these two things? I'm looking for a unit rate, right? What's the unit rate for this first scenario? $4.95 for 5 cans. That is 99 cents per can, right? For 1 can. All right, and then 6 cans for $5.75. So $5.75 for 6 cans, and you just do the division, right? 6 goes into 5.75, 0.96, right? Yeah, I think it's 0.96 cents. 0.96 cents for 1 can. So the better buy is the $5.75 can for that. Okay, so unit rates, unit ratios are very, very useful for comparing, finding the cheaper value or the better value or the greater of something if you wanted to. All right, so unit rates are great for comparing. All right, now this is converting rates. This is something that we've already done. We did it in Unit 1. We're revisiting it here again because it's a common thing that students struggle with. If y'all remember Test 1, this was kind of the most commonly missed question skill. A chemist raised the temperature of a liquid 45 degrees in 1 minute. All right. What is the amount, what is that amount, 45 degrees in 1 minute, in degrees Fahrenheit per second? So what are they asking us to convert here? Minutes to seconds. So we're going to start off by writing our given rate, 45 degrees Fahrenheit per 1 minute. And I need minutes to go away. I need minutes to turn into seconds. Okay? Now, what's the unit multiplier that I'm going to use to do this conversion?
60.
60 minutes, 60 seconds is 1 minute, right? But I need minutes to go away, so I want 1 minute on top equals 60 seconds on the bottom. And then what wants to happen happens here. Minutes cancel. And I'm left with 45 degrees Fahrenheit per 60 seconds. Now, is that the answer that they're asking for? No, because they want to know the amount per how many seconds? 1 second, right? So I need to convert this to a unit rate. 45 divided by 60 is what, Charlie? 0.75 degrees Fahrenheit per second. Okay?
We're doing this in science right now, too.
Are you? And your science teacher, if I'm not mistaken, is going to require you to show the unit multiplier.
Yes.
Yeah.
In certain instances, you have to, if yeah. So, and the reason that she does that is because you're going to be doing some things that are really, really complicated upstream from here. And you need to use that unit multiplier because, we'll do some things that are a little more complicated in this class too, but particularly when you start comparing volumes and areas where you have squared units, it just gets too confusing to not show the unit multiplier. All right? You're going to leave some points on your test if you don't. All right? Now, an engineer opens a valve that drains 60 gallons of water per minute from a tank. How many quarts were drained per second?
There's 4 quarts in a gallon. Yeah.
Yeah, so this is causing us to have to do 2 unit conversions, right?
Yep.
All right, so let's do it just as meticulously as we would if, we were somebody was really watching our work. 60 gallons per 1 minute, and we want to convert that to quarts per second. We got to use 2 unit multipliers, right? We need to convert minutes to seconds, and we need to convert gallons to quarts. All right, so I've got to get rid of minutes. 1 minute is 60 seconds. And I got to get rid of gallons, so I want to put the gallon on the bottom. 1 gallon is 4 quarts. Yes, it is 4, right?
Yeah.
Yeah, you can just cancel the 60s out.
Yeah.
Yes. So let's do our magic here. The minutes cancel. The gallons cancel. That's what we want. So we're left with quarts per second. The 60s cancel. And we're left with 4 quarts per second. Right? That's really easy. Now, this particular problem is really easy right out of the blocks. 60 gallons is per 1 minute, but you could just replace 1 minute with what? 60 seconds. That's 1 gallon per second, and 1 gallon is 4 quarts per second. Now, yes, but really, if you, this is the mental process that you have to go through, right? Is that less work? No, it's not. It's not less work. And which one requires more thinking? The second method. So which method is easier? The first method. If you follow your processes and you follow your steps, now, you could sit here and do this mentally and not have to put anything on the paper, but that's not going to be allowed. So your process has to be clear. But I just want to show you that the mental process involves how many steps? 3 steps.
Will you allow this for work in your class, or do we have to show that?
I want to see the unit multipliers. Because part of my job as 8th graders, 9th graders, as 8th graders is to get you ready for doing ratios and proportions in geometry next year. But as 9th graders to get you ready to do unit conversions in chemistry next year. Okay, so showing these steps is extremely important. Okay, I want you to be prepared for what's coming next. So I don't want you saying, Mr. Hinton, let me do it this way. I don't want you doing it that way. I want you to do unit conversions the way other people are going to expect you to do unit conversions. In chemistry, it's very meticulous. When you're doing with all the, balancing equations and all the stuff that you do in chemistry, it's very important that you have all your unit multipliers, all your ducks in a row, or all your whatever elements in a row. All right, next part of this unit is proportions. And a definition of a proportion, and there's another definition we've already had, but a proportion is an equation that shows 2 ratios are equal. And ratios are comparison of 2 numbers by division. So a proportion is a fraction equals a fraction. If we have 2 fractions equal to each other, that's a proportion. Is 3/5 equal to 9/15 in this example? In the example that's given here, are these 2 things equal to each other? So 2 equal fractions form a proportion. 3/5 is 9/15. They're the same values. So that's a proportion. Now, when we have a proportion, we can use cross products, or we can cross multiply. All right? If A over B equals C over D, right? And of course, B can't be 0 or D can't be 0, because then you'd be dividing by 0. Then A times D equals B times C. All right? Those are called cross products. In geometry, you'll talk about the means and the extremes. Right?
Do we need to write down the cross product?
Yeah, I would write this first line for sure. If A over B equals C over D, leave out this part because that's understood at this point. Then AD equals B over C. Excuse me, AD equals B times C. Whoa. All right. Now, what this means is that we can use cross products to undo proportions, right, to solve equations. If we have a proportion, we can use cross products to solve it. And you should. It's the easiest way to do it. All right? Has everybody got that written? A times D equals B times C. All right, so proportions are used to represent many real-world situations that require finding a missing value. You'll do that a lot in geometry. Is geometry a real-world thing? Yeah, because you got to take it next year, and this is your real world, your students. Okay? When are we going to have to use this in real life? This is your real life. Right? Yes. Unless you're moonlighting as a doctor on the side. Right now, your real life is you're a student. Okay? So this is not unreal, imaginary life that you're living. This is real life. All right. using cross products is not an efficient method for solving proportions. So, use cross products to solve here. X over 15 equals 2 over 3. How'd you get that?
Just
Have to,
divided.
30.
Somebody said they just divided.
I divided 15 by
30
3
and
and
then 30
multiplied it by
divided by
2.
3.
So this is the lazy man's way to do it. Y'all listen up. 3 times 5 is 15. 2 times 5 is 10. That's the lazy man's way to do it. And the reason I call it the lazy man's way to do it is because we're not using procedure to do it. All right? And we're going to run into a lot of problems where we can't think our way through it. If you can't think your way through it, then you have to know the process of it. And the process for solving proportions is to use cross products, right? So 3x equals 30 is what we get when we use cross products. 3 times x, 2 times 15, divided by 3, x equals 10. Now, in the amount of time it takes you to think your way through that, you can solve it and do a whole lot less thinking. Now, I'm not against thinking. I'm not against mental processes, but we're going to be solving problems that are more and more complicated, and the process is more important than the answer. All right, here's another one.
What's the lazy man again? I forgot.
X minus 1 over 12 equals 1/6. Now, you could still reason your way through this one, but the one coming up in a minute, you're not going to be able to, right?
Oh, that's
All right, now what you have to remember here, guys, is the fraction bar is a grouping symbol, right? So we've got parentheses around the numerator there, which means when we cross multiply, what do we have to do? Distribute. 6 times x minus 1 is 6x minus 6, and 12 times 1 is 12. Now, incidentally, one day early next week, probably Tuesday or so, we're going to have a quiz on solving proportions, cross products. It's easy. The equations that result are going to be pretty easy equations. Some of them will have variables on both sides, but we can still handle that. Add 6 here, and you get 18. Divide by 6, you get x equals 3.
I have a question.
Yes?
Could I do 12 times 1 equals 12, and 12 divided by 6, 2, and then 2 plus 1 is 3?
Yes, you
Let's
could.
just add whatever. it is
Yeah,
to
you
that.
can. And that's another way you could do that. You can just multiply by 12. Now that kind of goes back to this. All right? How do we deal with fractions? You multiply by a common denominator to get rid of fractions. The 12s cancel on the left. 12 times 1/6 is 2. Add 1 to both sides, you get x equals 3. Okay? So our old method of getting rid of denominators still works. Right? It gets a little bit more difficult when we look at problems like this. Now, I want to talk to you here about how we would figure this out the lazy man's way, and I want to talk to you about how we would figure this out as a mixture of two things, because you're going to do a lot of mixture problems in chemistry. Okay? The ratio of boys to girls in a math class is 3 to 2. What's the ratio of boys to girls in this math class?
So there's 3, 3, 4. No.
Make a table, 3 and 4.
Boys to girls is 3 to 4, right? No, I don't want you to make a table. The class has 25 students in all. How many boys and how many girls are in the class? 15 and 10, right? How did you get that?
Good. 25 divided by 5.
There's 5 parts, right? 3 boys to 2 girls. There's 5 partitions, but it means each one of those partitions is 5 people. And then there's 3 times 5 is 15, and 5 times 2 is 10. All right, so that's the way you can kind of, and I call that the lazy man's way. I'm also going to call that the way that you don't show any work on a test and you don't get any credit for your answer. Okay, now.
Can you like write out like what you're doing with that?
No, I want to see it. I want to see a specific way because here's why. You have the ratio of salt to water in a mixture is 3 to 2. And there's 17.2 kilograms of the mixture. Okay? Or you might have something else. So we're going to be getting into some issues where, you're going to work yourself a little bit harder. It's not going to be as obvious, and when it's not as obvious, you need a process that's going to work every single time. So here's the process, and then we'll talk about the why as we go through it. Just define a variable to be one of your variables, right? So let's let x equal boys. If x is boys, what would girls be? No, we need one variable. All right, let's talk about it this way. If there were 5 boys, how many girls are there? it's 25 minus 5, right? If there's 5 boys, then there's 25 minus 5 girls. If there's 8 boys, then there's 25 minus 8 girls. If there's 10 boys, then there's 25 minus 10 girls. If there's X boys, then there's 25 minus X girls. All right, so 25 minus X girls. All right. Okay, now the ratio of boys to girls is equal to 3/2.
Oh, okay.
All right. Now, this method will help you solve any proportion problem, any mixture of two things. Okay. So this is a good solid process that you can use for all these. Now, is it as simple as adding 3 and 2 and dividing that into the total? No. It's not. Okay. But it's going to help you reason your way through some more complicated problems. Cross multiply, and we get 2x equals, remember, parentheses here, 75 minus 3x. And we get that by doing cross products. 5x equals 75. When you add 3x to both sides, x equals 15. So there's 15 boys, 10 girls. Okay? It's not bad. You just have to remember that if you have two parts of a whole, if one of them is x, then the other one is the total minus x. Right? If you've got 75 pounds of potatoes and onions, if you have x potatoes, then you have 75 minus x in onions. Okay? So that gives you a comparison that has one variable, and that's easier to solve. Now, when we do systems of equations, we might look at using an x and a y here that would help us do it. Right? All right? So, next example. We're getting close. We're getting close. We're making good time. You guys will have some homework time today. On the map, Albany to Jamestown measures 12.6 centimeters. Jamestown to Springfield measures 9 centimeters. And Springfield to Albany measures 4.75 centimeters. What is the distance from Albany to Jamestown to Springfield and back to Albany? And we've got this little deal there. So Jamestown to Springfield. So Jamestown to Springfield. Oh, oopsie. Jamestown to Springfield. Springfield to Albany, and then back to Albany. No.
You would go from Jamestown to Springfield.
Albany to Jamestown.
Albany to Jamestown. Jamestown to Springfield, back to Albany.
So 1, 2, 3. You have to make sure that it's literally all the way around, right? And that's why I drew that picture there, and I drew it wrong first time, didn't I? All right. What state is this, you think?
Illinois.
No.
To New York.
New York is
New York.
Albany.
It's
Well, New
Virginia?
Yorkville, Illinois.
Yeah, I mean, I would think this is probably
New York.
all New
But it's
York.
Albany, Illinois, and
Illinois.
Virginia all in one.
Yeah.
Well, maybe not. I mean, there may be a Jamestown,
Okay.
New York. I don't know. Anyway, Albany. So what's the total distance around these in centimeters? 21.6 centimeters plus 4.75. what is that? 21 plus 4 is 25, plus 1.35 is 26.35 centimeters total.
Yeah, times that by 25.
All right? So now we're going to use that distance and this little hidden scale factor down here. All right? 23.65,
Times 25.
excuse me, 26.35 is
658.
X kilometers compared to 1 centimeter is 25 kilometers. And then when you cross multiply, you get,
658.75 kilometers.
you multiplied it already?
Yes, sir.
All right, we'll go with him. X equals 600,
Hang on.
you cross multiply.
Why can't you maybe, unit, what's it called? This. You just multiply. Why can't you do that?
Add the centimeters and
Do
multiply by
what?
25.
You could, but I'm just going with the directions here.
With the lesson.
Yeah, proportions. So I'm going to use the ratios that they gave us there. I'm going to set it up. All right, so we multiply 26.35 times 25, and that gives us, say it again, Charlie?
658.75 kilometers.
658.75 kilometers. I'm going to put a question mark there because I haven't confirmed that. But that seems reasonable, right?
Yeah.
25 times 25 is 625, so it's a little more than that, so I think we're good. I think that's a reasonable answer.
I didn't get that.
Okay? What'd you get?
I got 653.
653.75?
Here,
That would have been smart. To calculate.
This is 25 times 26.35.
26.35.
Yes.
658.75. All right? Good deal.
Great.
I was confused on how that ended in a.
All right, last one. Mr. Jackson drove a truck 300 miles in 6 hours. So what does that give us? That gives us a rate, doesn't it?
Yes.
300 miles per 6 hours. How long will it take him to drive 450 miles?
Oh, come on.
That's pretty easy, isn't it?
Yeah.
9.
Equals, you could do 450 per X if you wanted to. All right. But you could also find the unit rate. 360 miles per 6 hours is 50 miles per 1 hour. And 50 goes into 450, 9 hours is what we're looking at there. Right? Now, I want you to have some good processes here, though, right? The process would help you. You could solve the process with anything. So 50 to 1 is 450 to X is another one you could use. Cross multiply. 50X equals 450. 450 divided by 50 is 9. All right, so that's kind of a solid process that you could use. I want to see work. I want to see. I can't see what's going on in your head, so I want to see the process that's taking place. Here's your homework for today's lesson. Quiz tomorrow for you guys. I don't want to punish